Hello future learners, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a series of problems 41 to 43, and in this series of problems, I will discuss and present solutions to problems created and given in the prelim exams in the university where I am teaching hydraulics. And this video discusses problems covering topics from fluid properties up to buoyancy and statical stability of floating bodies. So these three problems are just the first part. So I hope that you enjoy and you learn from the solutions to these problems. Problem 44. Oil has a specific gravity of 0.8 in the differential manometer shown below. Determine the difference in pressure between A and B in kilopascals. Also express this pressure difference as pressure head in meters of alcohol with specific gravity 0.72. So here is the given figure. For the solution, let's call this height of water as H as shown. Then we mark important points here, A prime, here C, D, D prime, same pressure, then B prime, same as that of B. So sum of pressure from A to B, and by the way, this is H plus 0.3, then minus 1.2, this height here, H plus 0.3 minus 1.2, so H minus 0.9 as shown. So sum of pressure from A to B. So from A, we jump to A prime because pressure at A is equal to pressure at A prime. So P sub A minus 9.81 times H. Then C to D minus 0.8 times 9.81 times 0.3. Then from D, we jump across to D prime. So the equation is unchanged. Then D prime to B prime. So we go down, so plus 9.81 times quantity H minus 0.9, then equals pressure at B prime, which is pressure at B. So simplifying, pressure at A minus 9.81 H minus 2.3544 plus 9.81 H minus 8.829 equals pressure at B. So take note that we can cancel out 9.21 H and negative 9.81 H. Then combine 2.3544, 8.829 to the right, they become positive. So P sub A minus P sub B equals 2.3544 plus 8.829, and that is 11.18 kilopascals. So expressing this pressure difference in terms of pressure head in meters of alcohol, we simply divide this by the specific weight of alcohol, which is 0.72 times 9.81. So equivalent pressure head of alcohol is pressure at A minus pressure at B over specific weight of alcohol. So it is 11.18 kilopascals over quantity 0.72 times 9.81. So the equivalent pressure head in meters of alcohol is 1.583 meters of alcohol of specific gravity 0.82. Level 69, the 3-meter plank shown in section has a density of 800 kg per cubic meter and is hinged about a horizontal axis to its upper edge O. Calculate the angle theta as shown by the plank with horizontal for the level of fresh water shown. So this is the uniform 3-meter plank. So the weight acts at the center of gravity, which is 1.5 meters from O and 1.5 meters from this end, half of 3. So weight is density of the wooden plank times G, so it becomes unit weight times area of the end section of the plank, which is constant,
times length 3 meters, or volume of the plank. Then this part that is submerged, we'll call the length submerged as x. So that's 1.5. And therefore, this is 1.5 cosine theta, because this is theta. So hypotenuse times cosine of the angle. So 1.5 cosine theta. The distance, horizontal distance of the weight from this pin here, or hinge, axis of the hinge, O. Because we plan to sum up moments about O later, equals 0. For the buoyant force, let's call this x the submerged length. So the centroid would be at the midpoint of that submerged part, and that's where buoyant force acts, which is specific weight of water, 1000 kg per cubic meter times g, so that would be newtons per cubic meter, times volume displaced, which is area, cross-sectional area A, which is constant, times length submerged, which is x. And this distance is, because this is theta, is x over 2 cosine theta, or 0.5 x cosine theta. So that's 0.5 x, or x over 2 cosine theta. Therefore, this distance is, because the entire horizontal projection of the plank is 3 cosine theta, and there is already x over 2 cosine theta here. So therefore, this is 3 cosine theta minus x over 2 cosine theta. So 3 cosine theta minus x over 2 cosine theta. Then summation of moments about O equals 0. So buoyant force times quantity 3 cosine theta minus 0.5 x cosine theta equals weight times 1.5 cosine theta. Cancelling out cosine theta and replace buoyant force with 1000 g ax times 3 minus 0.5x equals weight 800 g area times 3 times moment arm 1.5 after we cancel cosine theta. Cancel out GA also and divide everything by 1000, so that what remains here would be x times 3 minus 0.5x, or 3x minus 0.5x squared. Then 0.8 times 3, 2.4 times 1.5, 3.6 on the right side. So 3x minus 0.5x squared equals 3.6. Rearranging, 0.5x squared minus 3x plus 3.6 equals 0. So using the calculators by quadratic formula, so x is 4.342 meters and x is 1.658 meters. Because 4.342 meters exceeds the length of the plank, so it is an absorbed value. Therefore, the acceptable value of x is 1.658 meters. From the figure, sine of theta is 1 meter divided by this length. So this length is 3 minus x. So sine theta is 1 over 3 minus x, and x is 1.658. Solving for theta, theta is equal to 48.17 degrees.
Problem 46. An automatic valve consists of a 900 by 900 mm square plate that is pivoted about a horizontal axis through point A. If the valve is to open when the depth of water is B equals 1.8 meters, determine the distance h from the bottom of the valve to the pivot A. So here's the given figure. Then D is, for the solution, D is 1.8 meters. A should be, by analysis, should be the center pressure as shown, and G is above, because when the force acts at A just above, then the gate will open. So the idea, therefore, that is that the line of action of F passes through A, and A should be the center of pressure, so that if F is just above of A, then the gate will open. So therefore, the distance between G and A is denoted by E sub V. And if we set up equation for H, because the distance of G from the bottom is half the height of the gate half of the height of the gate is 0.45 perpendicular to the board 0.9, because this is square. So H is 0.45 meter or 0.45 meter, the distance of G from the bottom is 0.45 minus E sub V, because this is 0.45 also. So H is 0.45 minus E sub V, and E sub V is height of rectangle square over 12 Hg, where Hg is 1.8 meters distance from G to the water surface, 1.8 meters minus 0.45, and that is equal to 1.35 meters. So substitute into this equation, the height of the rectangle is 0.9 meter, so E sub V is 0.9 square over 12 times quantity 1.35. So E sub V is equal to 0.05 meter. Then finally we can solve for H, 0.45 minus 0.05. So H should be equal to 0.4 meters. 0.4 meter. Problem 47. The 5 meter wide sluice gate AB shown tangent to the vertical wall at A holds back water. The surface of the gate in contact with the water can be taken as part of a cylinder with radius 4 meters. Determine 47.1 the horizontal force in the curve, 47.2 the magnitude of the resultant force on the curve, 47.3 the location of the line of action of the vertical force from A, and this is the figure. So for the solution, for the horizontal component of force on the curve, we draw horizontal lines through A and B to define the vertical height of the projected area of a rectangle, which is 5 meters wide, and this is the height, which can be computed as 4 sine 30. So that's 5 meters. So this is the centroid G, and therefore this is, from this right triangle, 4 sine of 30 degrees, and 4 sine 30 degrees is 2 meters. So this is also 2 meters. Therefore, Hg, the distance of the projected area, centroid of the projected area to the water surface, is 1 meter plus another half of 2, which is 1 meter. So Hg is equal to 2 meters. Fh acts below the G at the distance E from G vertically. We call that E sub V. And this is Hg, which is 2 meters. So Fh is specific weight of water, Hg times area, or specific weight of water, Bardade's area, where Bardade's is also Hg. So gamma of water is 9.81, Hg is 2, and the area is 5 times 2 as shown in the figure. So that's the area. So Fh equals 9.81 times 2 times 5 times 2. So Fh can now be computed. It is equal to 196.2 kilonewtons. For the vertical component of force, we draw vertical lines through the ends of the curve A and B up to the imaginary or real liquid surface, and the volume to be considered is the one that is enclosed by the vertical lines, the curve, and that imaginary water surface, which we will cross hatch as shown, and we will call this area 1, and this one, which is a segment of a sector, as area 2. Then the area is area 3 for this total shaded hatch. The volume, therefore, because FV is specific weight of water times volume, the volume is area 3, which this is area 3 times 5 liters into the board. So FV equals gamma of water, area 3 times 5 meters. So for area 3, that's area 1 plus area 2, and area 2 is area of sector minus area of this triangle here. For the sector, the area is, you should know the area of sector from plane trigonometry, 1/2 of radius square times central angle 30 degrees but converted to radians. If you do not know the area of sector until now, then that's your problem. You're a civil engineering student. You should know the area of the sector by experience, or that's a topic in plane trigonometry. And if you do not know, then you can derive the area of sector as to central angle of sector, which is 30 degrees, equals area of circle. The central angle is area of sector as to central angle, let's say theta, equals area of circle pi r square as to central angle of circle in radians is 2 pi radians. Then from there you can derive 1/2 r square theta in radians as area of sector. while the area of triangle is 1/2 base times height, or 1/2 product of adjacent sides times sine of the included angle. So this is 4 cosine 30, the base of this right triangle, hypotenuse cosine of 30, and that is 2 square root of 3 meters. So therefore, this width of this rectangle is radius of sector 4 meters minus 2 square root of 3. Use your calculator there, and that's 0.5359. Again, that's 4 minus 2 square root of 3, 0.5359. So area 2 is 1/2 radius square 4 square times central angle 30 degrees, or pi over 6 radians, minus 1/2 of 2 square root of 3 times height 2 meters. So the area of sector, if simplified, is 4/3 pi. The area of triangle, if simplified, is 2 square root of 3. So area 2 can now be computed. It is equal to 0.72469 square meter. Therefore, area 3 is area 1, which is 0.5359 times 1, or simply 0.5359 square, plus area 2, 0.72469, and area 3 is equal to 1.2606 square meter. So having found area 3, then we can now compute FV. FV equals 9.81 times area 3, 1.2606 times 5. So FV is equal to 61.83 kilonewtons. So the magnitude of the resultant force, square root of FH square plus FV square. So F is equal to 205.7 kilonewtons. For 47.3, we use the principle that the resultant force F passes through the center of the circular arc or circular curve, and the distance of FV from A, we will define that as x, as shown in this figure here. Therefore, the moment arm of FV from C is 4 meters, or radius minus x, as shown. So that's F. If extended its line of action, it passes through the center of the circular arc, and we use Varigton's theorem to solve for x. So this is 4 minus x, and the moment arm of FH from C is equal to 1 meter plus E sub V, where E sub V is height of rectangle square over 12 hg, and height of rectangle is 2, hg is also 2 meters. So E sub V is 2 square over 12 times 2, so E sub V is 1 over 6 meters. Therefore, by Varigton's theorem, F times 0 equals, let's consider FV positive clockwise, so 61.83 moment arm 4 minus x, minus FH 196.2 times 1 plus E sub V, or 1 plus 1 over 6. So finally, it's only x that is the unknown here. Solving for x, x is equal to 0.2979 meter. Then let's solve for x by the harder way, because the harder way will let us recall basic formulas or geometric properties of sector, triangle, or rectangle, whatsoever, especially sector, which is not so used in your experience with solving problems. So let's have the review on sector. The centroid of a sector area lies on the bisector of the central angle, as shown, and the angle is now bisected, so 30 degrees, this is 50 degrees, this is also 50 degrees, and the location of the centroid is here. The general location of centroid along the bisector is 2r sine theta over 3 theta, where theta is half angle only, 15 degrees. So it is 2 radius times sine of 15 degrees, sine of theta, over 3 times theta, but theta in the denominator should be converted to radians. So 15 degrees is pi over 12 radians. So again, this is 2 times 4 sine of 15 degrees, sine of theta, over 3 times theta in radians, pi over 12. So using your calculator there, it is 2.6363 meters. So that's the distance from the center of the circular arc to the centroid, or sorry, center of sector to the centroid of sector. Take note that we treated this as area, not an arc. Then we need this distance horizontal projection of that centroid, because it is the horizontal projection that is required. Then this is hypotenuse 2.6060 cosine of 15. The angle is 15. Imagine right triangle. And that is 2.6360 cosine of 15, and using your calculator there, it's 2.5465 meters. Therefore, the distance, horizontal distance of the centroid of sector from A is 4 meters minus 2.5465. Therefore, is the radius. So 1.4535 meters. For the triangle, the location of the centroid is here, and from vertex C, it is 2/3 of this distance, 2/3 of 2 square root of 3. So using your calculator, 2/3 of 2 square root of 3 in decimal, that's 2.3094 meters. Therefore, the distance of the centroid of triangle from A is equal to 4 minus 2.3094, and that is 1.6906 meters. So we are now ready, because the last is just a rectangle. The distance of the centroid of rectangle is half of 0.5359, so there's no need to specify or label that. So by Brigdon's theorem, area, which is 1.2626, this shaded area here, area 1 and area 2 or area 3, is equal to area of sector, which is 4/3 pi, as I said. Then its moment arm is 1.4535. So x of sector minus area of triangle, x of triangle, then plus area of triangle, x of area of rectangle, x of rectangle. So 1.2606x is equal to 4/3 pi times 1.4535 minus area of triangle 2 square root of 3 times x of triangle 1.6906, then plus area 1 or area of this rectangle 0.5359, and its distance, the distance of centroid from A, is 0.5359 over 2, as shown. So from there we can solve for x, and x is also equal to that. So take note that x is the centroid of this shaded area, which is actually centroid of the volume, which is half of 5 meters. It occurs at 5 meters. So the centroid in this projection front view is the same. So it is 0.272979 rather. So that's it, and I hope that we're able to recall location of centroid of sector especially.